There we go. So, here's the thing. Today we're going to divide. We're going to divide. We've multiplied, we've added, we've subtracted. The only thing we haven't done yet is division. So we're going to divide division of polynomials. Polynomials divide just like any number. So we're going to start with an easy example. We're just going to divide 6th grade. We're going to go back to 6th grade math. We're going to go 5 into 431. Now we want to show this because the same process that we do 6th grade math division will be the same process we do in example 2. Exact same process, except there'll be x's and x squareds instead of numbers. Okay, so first of all, the way we divided in 6th grade, we looked at the 5, and 5 doesn't go into 4, but 5 goes into 40, right? So 5 goes into 40 8 times. Everybody agree with that? So we go 8. So 5 goes into 43 8 times. And then we multiplied, didn't we? We multiplied 8 times 5, and we got 40, right? Okay. Then we subtracted, right? Everybody's done this before. 43 minus 40 is 3. And then, boys, pay attention. Shh. Then we brought down the next term, right? We just brought down the next term. We got a 1. And then we did it again. 5 goes into 30 6 times. We multiplied, right? 5 times 6 is 30. And then we subtracted. 31 minus 30 is 1. Now, what we aren't going to do is this. We're not going to go remainder 1.
Add a 0.
We could add a 0, and we keep dividing, but we're not going to be able to do that here. So what we're going to do instead is have it as a fraction. So my answer is 86 and 1/5, okay? Which would also be the same thing as 0.2. That's what you guys got, right? Now, the exact same process we did here, we also do with polynomials. Okay, so let's set up the next one. I'm going to go slowly. You have to pay attention. So we're going to take x plus 2, divide it into 3x squared plus 2x minus 5. Okay, set up the problem just like long division. Okay, write that down. Write that down. Victor, you guys paying attention? Of course you are. Now, same thing. But we go with x. We divide with the x. And x goes into 3x squared. Just like 5 goes into 40, x goes into 3x squared. Well, it goes in 3x times. But if you don't see that, you can do a little bit of division on the side. A little side division. A little side division.
We didn't do this in 6th grade.
No. So if you took 3x squared and you did divide it by x, hopefully you can see that that really is, here's my side division, it's really a 3x. So x goes into 3x squared 3x times. Then what we did up here is we multiplied. We went 8 times 5. So we're going to multiply here also. We're going to go 3x times x and 3x times 2. We're going to multiply. I'm going to get a 3x squared plus a 6x. Just like above, I'm going to subtract. But I got to be careful. So for me, I bring the negative through. I add a negative because sometimes I make mistakes and I forget to subtract that one. So what I do, I like to bring the negative through. So I like to change my signs and I make that, I change the signs, and then I don't tend to make a mistake, okay? I brought the negative through. I added a negative, and now I'm not going to make a mistake because 3x squared minus 3x squared. 2x subtract 6x negative 4x. All right, so I'm going to bring down the next term just like I did this one. I'm going to bring down the next term, so I'll bring down the negative 5. So I'll do the same process. I'll bring down a negative 5. And I'll divide again. So then I'll say again x, but this time just like the 5 went into 31, x goes into negative 4x. It's just like the 5 goes into 31, I'm going to do x goes into negative 4x, negative 4 times. And again, if you can't see that, you get a little side division, and hopefully you'll see negative 4, okay? So what did I do up above? I went 6 times 5 is what I did up above. So I'll do the same thing here, and I'll multiply. I'll go negative 4 times x and negative 4 times 2. I will get a negative 4x squared, negative 4x, I'm sorry, minus an 8, okay? And then I subtracted up here, right? I subtracted. I will also subtract here. And this is where it's important for me, because I make mistakes. So I'm going to subtract a negative, I'm going to subtract a negative again, right? So what I do, so I don't make a mistake, is I add a negative. I add a negative. I'm going to add a negative, which is the same thing as subtracting. So I add a negative, so I'm changing these signs. Okay? I add a negative so I don't make a mistake. I'm still subtracting. Cancels. And then I get a 3. Now, up above, 5 would not go into 1. That became my remainder. Here, x will not go into 3. That becomes my remainder, okay? So then what I do is I took my 1 over my 5. That's what I did for my remainder. Here I'll do the same thing. I'll take 3 over my x plus 2. So my answer is this. It is 3x minus 4 plus 3 over x plus 2. It's a hard lesson. It's a hard lesson. We can do this, though. Yep, we can do this. Okay, now let's turn the page and practice again. Okay, so I got one more problem we should practice. Okay. Okay. Example 3. Yes. Yes. Okay, example 3. So let's divide x squared plus x into x cubed plus 4x squared minus 4x plus 5. Okay? So the process is not that different than long division. It is long division, but with x's instead of numbers. So we're going to do the same process. All right? We are going to divide by the first term. We're going to divide by the x squared. So x squared goes into x cubed. Well, if you're not sure, this goes into this. That's why I like my side division. So my little side division, if I said x cubed divided by x squared, hopefully you can see that's x. That's my side division, okay? So if you're not sure, x squared does go into x cubed, x times. And then, just like long division, we would multiply, right? We would multiply. So I'm going to multiply, and I'm going to multiply my x times x squared and my x times x. So x times x squared is x cubed plus x times x is x squared. I'm going to subtract, right? I'm going to subtract because that's what I do with division. I subtract. I tend to make mistakes, so I'm going to bring the negative through. I'm going to add a negative. So I bring the negative through. I add my negative, and then I tend to make less mistakes. That is a 1, invisible 1, and I subtract. So I brought my negative through, changed the signs, because I'm adding a negative. Subtract, it's gone. X cubed minus x cubed. 4x squared, subtract 1x squared is a 3x squared. Okay. And just like long division, we'll bring down the next term. So we bring down the next term. And I get a negative 4x. Now we're going to divide again. And just like the long division, now 5 went into 31. We're going to take x squared goes into 3x squared. So we're going to divide x squared into 3x squared. So again, if you can't see that, do a little side division. And I think you'll see it goes in 3 times. So I know that x squared goes into 3x squared 3 times, positive 3 times. And I'm going to multiply. Just like in long division, I'm going to multiply that times that times that. So I will get a 3x squared plus a 3x, and I need to subtract. I like to add the negative, so I bring the negative through, I bring the negative in, because that is still subtraction. I add a negative and I add a negative, I change the signs. 3x squared minus 3x squared just cancels. Negative 4x subtract 3x is a minus 7x. Now bring down the next term. So bring down my plus 5. Now x squared does not go into 7x. It won't. In fact, I'll show you. A little side division. If I went negative 7x divided by x squared, I wouldn't get an answer that I could use. Because this is a bigger degree, it won't divide into this one. So this is my remainder. So I'm going to take, like I did over here, I took my 1 over 5, made it into a fraction. I'm going to take my negative 7x plus 5 and put it over my x squared plus x. Now, my answer then is all of this. It is x plus 3 plus a negative 7x plus 5 over x squared plus x. This is hard, isn't it?
Yes.
Now, I could work with you on your homework and we do it together, and then we could have as much as a half hour to work on our egg drop, okay? You want to do that? Should we just get it done?
Sure.
Okay, let's just get it done.